How fast is the universe expanding? Well, depending on where you look, you get different results, and that's a problem. This is the crisis in cosmology. Let's break it down further. Astronomers measure the expansion rate of the universe called the Hubble constant using two main methods. The first method involves measuring the cosmological redshifts of several very distant galaxies, which quantifies the extent to which light waves from these galaxies stretch as they travel through our expanding universe. Astronomers use these redshift measurements to calculate how fast these distant galaxies appear to be moving away from us. Next, astronomers climb the cosmic distance ladder, where they use distance measurements of objects that are progressively farther and farther away, as well as special types of supernovae called Type 1a supernovae to calculate the distance to these distant galaxies. Then they combine that data with the redshift measurements to get a Hubble constant of around 73 megaparsec per kilometer per second, meaning that galaxies 1 additional megaparsec away recede by an additional 73 kilometers each second. Now, the second method involves extrapolating from the beginning of the universe. If we know the state of the early universe, and we also know the ingredients that make up our universe, we can model how it evolves, and then compare those models to how the universe actually looks like today. And astronomers find that one key ingredient is always present when an identical model universe is produced: a Hubble constant of around 68 megaparsec per kilometer per second, a value significantly different from the previous value of 73. So, who's right? Well, no one currently knows, but there are a lot of proposed solutions. Ultimately though, solving this crisis might just be our next step towards fully understanding the nature of our universe.